This is Unit 2, Lesson 2, working with transformations of square roots, quadratics, and absolute value functions. So by the end of this lesson, you should understand how to perform translations, dilations, and reflections on these three different functions. All right, let's first start by taking a look at the parent functions for each graph. So what is a parent function? It's the simplest function of a family of functions, meaning a family would be the quadratics, that parabola, that U shape. Square root graphs and absolute value graphs have their own families as well. And it's the simplest form. The graph has not been shifted, it's not reflected or dilated. And when you look at the three different equations, you can see that there's nothing added or subtracted, nothing's being multiplied, there is no negatives there, okay? So it's the simplest form. So what we need to first start by is looking at what our quadratics and square roots and everything look like. So let's start with our quadratic graph. Okay, it is a U shape. And one thing to know about all parent functions that we're looking at have a vertex or a starting point at 0, 0 at the origin. So that point is right here. So now anytime you need to graph a function, if you don't know where your points are, you can always create a table of values. Plug in a few x values, get the corresponding y's, and plot those points. Sometimes what can be tricky though is as we're shifting it around, you want to make sure you're using the right x values so that you're getting that whole U shape in your graph. Okay, so what we're going to take a look at is how to graph it using a pattern as opposed to a table of values. But of course, once again, a table of values is always your go-to. So in the quadratic, there is a pattern that teaches you how to get from one point to the next. Let's move this up 1 second, please. So our pattern is going to help us to get from one point to the next. So if I'm starting at my vertex at 0, 0, to get to my next point, I can go 1 to the right, and then I can go up 1. After that, I can go 1 to the right and up 3, 1 to the right and up 5, and 1 to the right and up 7. And we'll talk about why this pattern exists in just one moment. Okay, but once again, these are directions to get from one point to the next. So when I look back at the graph, from my vertex, I'm going to go right 1 and up 1. From there, right 1 up 3, right 1 up 5, okay, and then I've run out of room. Now if I go back to my vertex, I can just do the same thing going to the left. Left 1 and up 1, left 1 and up 3, left 1 and up 5. All right, so I have a beautiful shape, and I can go ahead and draw a U. Okay, now remember, this is not a V, I don't have rays, I don't have any straight lines here because the rate of change is not constant. The height between each point is changing. All right, why? Because you're squaring your x. So if I take a look at this graph, if I were to look at this first point over here, this point right here has an x value of 1. And we know 1 squared is 1. So the coordinates of that point are 1, 1. If I go over 2 from my origin, the y value is 4 because 2 squared is 4. If I go over 3, I end up going up 9. Okay, so those are the coordinates of the point, and if you notice the difference between perfect squares has a pattern. It has a difference of 3, 5, 7, etc. So the pattern can help you get from one point to the next. It's not giving you the coordinates of your points. It's telling you how to get from one point to the next. Okay, so why are we going to use that? Because as we introduce the dilations and the changing this vertically, horizontally, stretching and compressing, using this chart right here will help you, and you'll see momentarily. Okay, now a quadratic graph increases in height quicker than it stretches out wide. A square root is going to be the opposite or the inverse of that. All right, so it also has a vertex at 0, 0, and it also has a pattern, but it's going to be essentially the opposite. The amount that I go up and over is switching places. So if I were to draw this chart, and once again, these are just directions to get from one point to the next. They are not coordinates. But from my vertex, I can go right 1 and up 1. I can go right 3 and up 1. I can go right 5 and up 1. Okay, so looking at my graph, I notice it's kind of like a sideways half, well it is, it's a sideways half quadratic. Okay, why? There's a restricted domain here, guys, because if I were to look back at the function, and I can't take the square root of a negative number. So I can't have any negative x values in my parent. As we shift it around, there will be, you'll have some negative x's in there, and we'll talk about that later. But for right now, I can't take the square root of a negative 4 and get a real number. I'll get an imaginary, which we get into in a few units, but for right now, I can't get a real number. All right, and I can't have a function down here and have it be the same because, hey guys, that's not a function. It will not pass my vertical line test. So we're just taking the positive square root of our numbers. Okay, so our quadratic, it increases more than it stretches sideways, and our square root stretches sideways faster than it increases. All right, and then your absolute value also has a vertex at 0, 0, and the parent function just has a pattern of up 1 over 1. Okay, and we've seen that before. For some reason this side of my board is not calibrated. So I'm doing the best to get it on the points. Oops. Okay, so there's my V. Sorry. All right, so the pattern there is up 1 over 1, and that will just help us out as we're, once again, working with the compressions and stretches and all that good stuff. Okay, so parent function of a quadratic makes a u. Parent function of a square root makes a sideways half u, really. All right, so let's take a look at now adding some in. We're going to start with translations and reflections, and then we'll add the dilation piece in. All right, when we start doing multiple ones, you always want to work with your reflections and your dilations first, and then the last thing you want to do is translate it around. Okay, now some people will be able to go right to the final graph. Some people will need to piecemeal it, and that's what I'm going to do here. I'm going to show you each little change until we get to the final graph. So the first thing we want to decide is the shape of this. Okay, this is a square root. So I'm going to go ahead and draw my table to help me. Square root was 1, 1, 3, 1, 5, 1. And once again, this will really help you when we start adding our multipliers in there. So for right now, it's kind of just giving us some guidance. All right, and then I want to decide what types of transformations are happening. So since I've got a +3 on the inside, it's moving it sideways in the opposite direction. So this graph is going to shift left 3. All right, this negative on the outside is going to reflect it, and because it's on the outside, it's moving it up or down, so I'm going to reflect over x. Okay, so my y values are going to change. So some of you, once again, could just graph this, taking a square root, shifting it, and flipping it all in one shot. I'm going to go ahead and do it piece by piece. Start off by plotting the parent function. So I'm starting at 0, 0, up 1 over 1, up 1 over 3, up 1 over 5, and that's my parent function. So nothing's been done to that. Okay, now remember, we want to take care of our reflections and our dilations first. So the first thing I'm going to do is reflect it over x. So all of these points I'm reflecting over x. Or I can think about it, as opposed to going up 1, I'm going to be going down. So those become negatives. Okay, so I'm going down 1, 1 to the right, down 1, 1, 3 to the right, 1, 2, 3, down 1, 5 to the right, 1, 2, 3, 4, 5. So this is the graph of y equals negative square root of x. Excuse me. Now to get my final graph, I'm going to take that red one and shift it. So I'm just doing each transformation one at a time. Okay, so I could sit here and count each point 3 to the left, or if I realize, hey, my vertex just moving left 3. Okay, my vertex is now at negative 3, 0. And then from there, I can just follow my pattern, or I can count out each point. Okay, but this is my final graph. This is y equals the negative square root of x plus 3. All right, my next graph, once again, decide your shape first. This is a U, a quadratic. Okay, let's draw our table. This 1, 1, 1, 3. So it's flip-flop of the square root, remember that. The amount that it increases is different than in our square root. All right, let's go ahead and plot that first before we talk about our changes. So I'm just following my pattern to plot my points. Just counting. All right, now let's take a look at what's going on. So I've got a reflection, but notice it's inside. So because it's inside, I'm reflecting over y this time. Okay, so that's going to take my x values and I'm going to negate those. We'll come back to that in a minute. And the last thing I'm doing is I'm moving up 1. Now guys, let's think about this. If I'm reflecting over y, what's going to happen? Nothing, okay? Nothing's going to happen right now because really this is just going to reflect upon itself. So if I were to trace it in red, it's just the same exact for now. As we start shifting things around, of course, movement will happen. But for right now, right there. And then I'm moving it up 1. So my vertex is at 0, positive 1. So every point just goes up 1. Oops, right there, sorry. Okay, so there's my graph. Okay, so let's go ahead, pause the video, please. I want you to try these two on your own. I'm going to pause it as well. Okay, so when you press play again, the answers will be up here. So go ahead and pause and give it a shot. All right, so take a look at my first one. Not too much happened here. I just shifted it right 1 and down 3. So my new coordinate is at 1, negative 3, my vertex. And then from there, I just follow my up 1 over 1, up 1 over 3 pattern. And so 1 in green is the final answer. On the right, you can see in blue my parent function, which is the u. And then in red, it reflected over x. And then I shifted it left 5 and down 2. Okay, so my new vertex is at negative 5, negative 2. All right, so let's go ahead and add some dilations in here. Okay, so we've got to decide inside, outside, all that good stuff. And the last thing we'll do is piece it all together. So this is a quadratic. Okay, so let's go ahead and draw our table because that's really going to help you here, guys. So for quadratic, it was 1, 1, 1, 3, 1, 5. Now, we don't have any negatives or shifts yet. We're just taking a look at it. So I want to decide what type of dilation is that. Vertical or horizontal, stretch or compression, and by what factor. So since this 2 is outside, it's not inside the function. If you look down at number 7, you can see what an inside the function would look like for a quadratic. See how it's inside the parentheses? Okay, so this one is outside, so that means it's vertical. And when it's vertical, it goes in the direction we expect. So this one is stretching by 2. So remember, on the outside, it's changing my y values. So I can just go to this table I created and multiply all of my y values by 2. And once again, this isn't giving me coordinates. This is giving me directions to my next point. Okay, so I can start at 0, 0 because it hasn't shifted. And I can go up 2 and over 1. And then it can go up 6, 1, 2, 3, 4, 5, and over 1. And then it could go up 10, but I ran out of graph. Okay, so the taller it gets, the less points you will actually be able to get on there. Right, and then just do it on the other side also. So this makes my quadratic skinnier. All right, my next function is a square root. So I'm going to go ahead and make my table again. Okay, this time oops, sorry, that should be a 1. 3, 1, 5, 1. Okay, so my number's inside this time because it's underneath the function. So that means it's going to be horizontal, so my x values will change, and this is going to be a stretch by 2. Don't forget, when it's inside, you're going the opposite of what you think. So that means it's affecting my x values. So this time I want to multiply my x values by 2. And by x values, I mean the directions on how to get to my next point. So I'm starting at 0, and I'm going to go to the right and up 1. Sorry, my board, it's the projector. It's not my fault. All right, 6, 1, 2, 3, 4, 5, 6, and up 1. And there's my square root. So it's kind of stretching it out so it's not getting as tall nearly as quickly. Remember, guys, to pause and rewind as you need. All right, this next one is quadratic, U-shape. Let's go ahead and make our table. Over and up, 1, 1, 1, 3, 1, and 5. Okay, now I see it's a 1/3 inside, so that means horizontal because it's inside, stretching by a factor of 3. So I'm multiplying my x values by 3. Starting at 0, 0, 3 to the right, up 1, 3 to the right, up 3, 3 to the right, up 5. And then I just do it in the same pattern in the other direction. 3. So it makes a nice wide quadratic. All right, and my last one on here is an absolute value, which is a V. Okay, so this pattern is just 1, 1 the whole way down until I change it. So I've got a 1/4 on the inside, so horizontal, stretch by 4. So that means I'm just going to go ahead and multiply all my x by 4. So it's just telling me I'm going to go right 4, up 1, right 4, up 1, or up 1 over 4, however you want to think about that. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. In the other direction, 1, 2, 3, 4. 1, 2, 3, 4. And there's my V. So I'm stretching it horizontally. All right, so once again, if you need to rewind, please go ahead and do so. We're going to go forward and combine all of these concepts together. All right, so once again, when you have multiple transformations going on, work with your dilations and your reflections first and then translate it, okay? If you go out of order, it can make a difference in the wrong way. So let's first take a look. This is an absolute value. Decide your function first. It's a V. Draw my table in case I need to change things. Okay, let's look at what's happening here. I have translation of right 4 and up 1. I have a reflection over y because it's inside the function. It's inside the absolute value signs. And I have a dilation factor of 2, which is on the outside, so that's a vertical stretch times 2. So if I come over here, I'm going to go ahead and I'm going to multiply, since vertical, my y's by 2. Okay, now let's go and draw the parent function. The more transformations we have, it's easier at least to draw the parent. Whether you're going to do every step or not, at least get the parent on there to help you. So here's my V. Okay, vertically stretching by 2. Now reflecting over y for right now is not going to do anything. Okay, so I'm going to vertically stretch by 2. So up 2 and over 1. That's in the red. All right, and then I'm going to go ahead and take this and move it to the right 4 and up 1. So my vertex is at 4, 1, and then from there I can do my up 2 and over 1. And so the green, sorry, it's a little wonky, but that's my graph. Okay, my next one is a quadratic. 1, 1, 1, 3, 1, 5. Okay, what's going on here? Let's see. We've got a translation of right 2, up 2. We've got a negative on the outside, so we're going to reflect over x. Reflect x. The 1/2 inside gives me a horizontal stretch of 2. So my x are being multiplied by 2 because it's horizontal stretch. And since it's a negative, technically, and that's on the outside, my y's are becoming negative, right? We're going down as opposed to up. That's all that's telling me. All right, so if you can handle it, you can do it all at once. We have all the tools, okay? When we're saying doing a reflection and dilation first, once again, if you can piece it all together, go ahead. We know what's going to happen. It's not as big of a deal. I'm reflecting down, so my vertex is going to end up at 2, 2, 2, 2, right here. I'm going down 1, 2 to the right, and 2 to the left. Just doing it in both directions. sorry, my board is so off. That's it. That points at 0, 1. All right, down 3, and then over 2. Down 3, over 2. Down 5, over 2. Same thing, down 5, over 2. There's my U. So an example of how I could get it all there. If you need to go piece by piece, draw your parent first, draw your reflection and your stretch, and then move it, please feel free to do so. Everyone works at their own pace. All right, I've got 2 more graphs to take a look at. Okay, so square root. One, 1, 3, 1, 5, 1. Not too much going on here. I'm moving it up 3. Okay, so moving up 3. And then I have an inside multiplied by 3. So that's a horizontal compression by 1/3. So it's going to make our points just a little bit funky because I'm multiplying the x's by 1/3. So I get 1/3, I get 1, and 5/3, or 2 and 1/3. Remember, those aren't coordinates, it's directions to the next point. So you got to keep that in mind. All right, so since I took care of that, there is no reflection. I can just do it all at once. Starting up at 3, and then I move 1/3 to the right and up 1. Just do your best. It's in there. I'm moving 1 whole thing to the right, so I'll be at 1 and 1/3 technically for my x value and up 1. Now from here I'm moving 5/3. So I'm currently at 1 and 1/3, and I'm adding 5/3. So that's 4/3 plus 5/3. So I'm going to end up at 9/3, which is actually 3. So if there is a whole point in there, you got to make sure you end up on it. So please just be careful. Ooh, and I can plot more. So 7 and 1. 7 times 1/3 is 7/3. So that's 2 and 1/3. So 1, 2, and 1/3 up 1. I can go 9 and 1. 9 times 3 is 3. So the compressions, guys, you're going to get more points. So 1, 2, 3, and that's the last point that will be on there. Okay, my last graph is an absolute value. 1, 1, 1, 1, 1, 1. I am moving to the left 4. I have a reflection over y. And I have a vertical compression of 1/4. So my y's are being multiplied by 1/4. Okay, so it's left 4. So the reflection we should have taken care of first, which wouldn't have affected it. So that's not going to change where I'm moving. Okay, now over 1 up 1/4 really is going to put you guys at up 1/4. But okay, so over 1 up 1/4, over 1 up 1/4. And my whole point ends up here. So it looks like this. All right, let's finish off with writing some equations. So the first one says, write the quadratic function that's been shifted 3 units left, stretched vertically times 2, and reflected over the axis, x-axis, and shifted 4 units up. So first of all, quadratic means x squared, right? We need to know that. So let's take each thing one at a time, shifting 3 units left, stretching vertically 2, reflecting over x, and shifted 4 units up. We'll do in, oh, I thought that would work. No, we'll do black. Okay, so when you're writing it, work inside out, okay? It'll just make it easier. So if I'm shifting 3 units left, we know that's inside. So I've got to put inside my parentheses, x, 3 units to the left really means a +3. The squared, guys, just tells you what function it is. Stretched vertically 2 times. Vertically goes on the outside, so multiply that by 2. I'm reflecting it over x, which means my y's are changing, so that's going outside, and I'm moving it up 4. So that is my equation. All right, this one down here, what happened? I moved it right 4 and down 2. There is no reflection, okay? There is no dilation because it's just 1, 1 all the way through. So it's pretty much just x equals absolute value of x minus 4 and then minus 2 on the outside. All right, now to end the notes, you can go ahead and check these on your own. The answers is posted, so if you want to go through, this is just kind of saying what's happening to each function. Okay, so for example, in this first one right here, oops, what is this 4 show? It's on the outside, so a vertical stretch by 4. So you can just kind of go through and write them out or just, say them and check your answers online. All right, that concludes our lesson.